Okay, so now you guys know about the trends in effective nuclear charge going across a period or down a group. We can talk about the trends in ionization energy. So remember, ionization energy is basically forming a cation, right? So it's technically defined as the enthalpy change for forming 1 mole of gaseous cations from 1 mole of an atom plus 1 mole of electrons. That's for the first ionization energy. And then, of course, you have subsequent ionization energy. So the second ionization energy is going to be removing 1 electron from a +1 cation, yada, 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 so on and so forth. So technically, we're just talking about their first ionization energies when we're talking about trends. Okay. So if we talk about going across a group, we know as you go, sorry, going across a period, as you're going across a period, you know that Z is increasing, but the amount of shielding is staying constant. So your effective nuclear charge is increasing, which means those outer valence electrons are experiencing higher nuclear charge per electron, therefore they get held in more tightly, so the radius is decreasing going across a period. So I'm sure you can imagine, okay, that the energy cost of removing an electron that is experiencing more effective nuclear charge and is being held in more tightly is going to increase. So ionization energy increases going across a period. And that really makes sense when you consider that the metals are on the left-hand side of the periodic table and the non-metals on the right-hand side. Do non-metals form cations? Not very often, right? So that explains that trend. As you're going down a group, we know each time you go down a group, you're increasing the principal quantum number by 1. So you're getting another shell of electrons. So those outer valence electrons are physically further away from the nucleus. The amount of shielding between the outer electrons and the nucleus is increasing as you descend each group, okay, which means the effective nuclear charge experienced by those outer electrons is decreasing. The radius is increasing, they're literally getting further away and they're feeling less charge. Therefore, it's going to cost less energy to remove them. So the ionization energy is going to decrease as you go down a group. Okay, so remember, ionization energy is usually positive number. So a big positive number means it costs a lot of energy to remove them, and a small ionization energy means it's really easy to remove them. So that explains an increase in reactivity going down group 1. Okay, so we're asked to rank the elements in terms of their ionization energy. So let's find them on the periodic table. So we've got bromine, and we've got indium, and we've got germanium, and we've got tin. Okay, so let's do some relative ordering. Okay, so whenever you got things in different groups and periods, just like pick 2 that you can compare and start from there. So I'm going to pick indium and tin because they are in the same period. So we know as we go across a period, ionization energy increases. Therefore, tin should have a higher ionization energy than indium. I think we're being asked from highest to lowest. We'll work it out. Okay, so let's pick another 2 that we can compare in the same period. So germanium and bromine. Okay, so we know ionization energy is going to increase going across a period. So bromine should have a higher ionization energy than germanium, not geranium, germanium. Okay, so then lastly, we have to compare the 2 that are in the same group. So we know ionization energy decreases going down the group. So germanium should have a higher ionization energy than tin. So can we now order these? Yes, we can. Germanium should be the highest ionization energy, then, hang on, germanium, then tin, and then indium is an order. I've got to fit bromine in there. Hang on, wait. I misspoke, right? Because germanium is greater than tin, and tin is greater than indium, but bromine is bigger than germanium, so bromine's got to go on the front there. Like, so obviously cannot hold like 3 pieces of information in my brain at the same time, which is why we compare 2 at a time, right? And we get this ordering. So I'm not sure if it ranks them like from 1 being the highest to 4 being the lowest, probably something like that. Okay, so just make sure you can get the order right, and then stick it in the ranking.